Okay, welcome back. This is part 2 of the CBT related to XEN, KVM, LibVirt and IPTables. Alright, we have already discussed the input rules on the input chain. Now let's discuss the forward rules on the forward chain. The first rule which gets added to the forward chain, over here it looks like the first rule. In your installation or configuration, this physdev rule might come at the bottom of the forward chain. Nevertheless, this rule says that add a rule to forward chain and use the module physdev, and if any packet is coming in through physical device through this physical device, which is, I've already explained, this is virtual interface 1.0, which basically means that virtual interface of domain 1, that is VM1 and Ethernet card 0 on that domain. So if any packet comes in, accept that packet. Right. The next rule states that if any packet, no, not if, the next rule says that add a rule to forward chain, and any packets which are trying to go to this network, which is the private network on the right side, any packet has a destination address of this IP subnet and is going out through the virtual bridge 0 outgoing interface and has a state either related or established, then accept that. That means any traffic which went out somehow from the physical host towards internet, initiated from virtual machine, crossed the physical host and reached internet, now it's coming back wants to go to the virtual machines, then naturally that traffic or those packets would have this state, related or established. So it's asking the firewall to accept those types of packets, and this is the actual rule which is accepting the traffic in the direction from right to left. And see, it says that add a rule to forward chain, any packets coming in from the source IP subnet or source IP scheme of 192.168.122.0 coming in from the virtual bridge 0 interface, they should be accepted. So this is the traffic from right to left, and this is the traffic from left to right. Alright, this is accepted. So this is forward chain, so any traffic which is trying to go out on any other interface, it's accepted. Then the next rule says that add a rule to forward chain, incoming interface virtual bridge 0, outgoing interface is also virtual bridge 0, then accept this traffic. This is basically one VM trying to communicate to another VM on the same switch. So virtual bridge 0 is the same, virtual bridge 0 is the incoming interface as well as the outgoing interface. That means from on the switch, if you look here, traffic coming in from a VM trying to go to a second VM naturally has to go through virtual bridge 0. So this rule accepts that kind of traffic. This rule, the next rule says add a rule to forward chain. If outgoing interface is virtual bridge 0, then reject, and reject with a message passing this message to the computer which sent the packet in the first place. The message is that ICMP port is unreachable. So there is a difference between reject and drop as well. I hope that you are aware of that. Reject would instantly send back a reject packet, whereas drop If drop is used, it would silently drop the packet without informing the sender. So reject is better in those situations where you do want to have a feedback in both success and fail cases, whereas drop, you use drop in cases where you don't want to respond back. The last rule says that if the incoming interface is virtual bridge 0, then reject the traffic. Since most of the conditions are already satisfied above, so these last two reject rules sort of act as a global reject policy for the output chain, for the forward chain here. Right, so this was the filter table. The NAT table has only few rules in the post routing chain. Basically, if this rule would have been there, it would have been enough. So the above two rules are extension to this rule, further broken down to the TCP and UDP type protocols, and the masquerading would always be done within this ports range or port range. So we can skip that to this rule, because this rule does this almost the same thing, which basically says that if any traffic is coming from this IP subnet, which is 192.168.122.0, and it's trying to go, destination is not the same subnet, that means trying to go out elsewhere, then masquerade that. Means replace the IP headers of that packet and replace those headers with the IP of the outgoing interface. The same is being done above. The only difference is here we are only dealing with TCP type of traffic, and here we are dealing with only UDP type of traffic. And notice that this is configured on the post routing when the packet is just about to leave an interface, an outgoing interface. Alright, so this was the rules, default rules, which are added by libvirtual service. I could have explained these rules by using this syntax, but this is kind of not optimal to explain, because the source and destination just says anywhere, anywhere. Sorry. And also it doesn't specify any interfaces. You can't see Ethernet 0 or virtual bridge 0 or any other name of interface in this kind of output here. That is why this output is not suitable for explanation. And I would recommend you the same, that whenever you want to have a detailed look at any rule, suppose this rule, which is totally vague here, it says accept all traffic coming from any source address going to any destination address. It's very vague. You're not able to understand anything out of it. This is well explained here, that the incoming interface, outgoing interface, and if any protocols are mentioned or not, whatsoever. So this is a better way to examine rules. Alright, with that said, let's move on and explain that what happens when I try to reach virtual machine number 1 inside my Xen host from outside. Let me show you. Virtual shell list --all. Virtual machine 1 is running, and its IP is, I believe, 192.168.122.41. Yes, it's pinging at least. I can show you the command prompt, virtual manager. All right. Okay, so let's click on this, press enter, and you see this login screen. The password on all these virtual machines in this test environment is Red Hat. Alright, so this machine has an HTTPD service running. Sorry, my throat is really bad again. Service HTTPD status. content is it serving? Let's remove any index.html files here, so I can show you with wget http://192.168.122.41, and this file is saved here. You can see index.html. I can do cat index.html, which is saved here, pulled from the web server, and it is serving this web content, private VM1 inside the Xen host, and it says another line as well, which is kind of confusing at the moment. So I will just edit this file and I would remove this second line. Don't worry, I'll show it to you again when there would be a need to. And let's remove this break as well. Okay. Okay, let's get the web page again. This time it is saved at index.html.1, so cat index.html.1. Perfect. So this is the message being or content being served from VM1, and we are inside VM1 at the moment. And to see if I get any traffic from outside, I would run a TCP dump on it. TCP dump port 80. This should be enough. Alright, so we minimize this, and now I want to show you one more thing, that IPTables minus list minus v will show you the stats or the counters of each chain and each rule. So the counters till now are as follows: that input chain has seen 18,714 packets in total, which is about 11 megabyte in size in bytes. These rules have not seen any traffic as yet, and the forward chain has also not seen any traffic on these rules. All these counters are 0 on the rules, and the forward chain has default policy set to accept. However, there has no packet which has crossed forward chain as yet. So the same we can use with the NAT table. You see that our rules are mentioned here. There are 39 packets which have crossed the post routing chain. All have been accepted. However, none of those 39 packets matched any of these rules. Therefore, you see 0 as counters here. That is not a problem. There are possibilities that there are packets or traffic which does not match your rules, so naturally it would not show up in the rules, but it would show in the total figure here shown on the top of each chain. I'm really sorry for my throat. Means if you are getting disturbed because of it, I cannot find a cure for it as yet. Alright, moving on. Let's try to reach according to this diagram. This is my laptop here. I would try to reach the web page of my VM1 here on the Xen host. So I would try to reach through 1.201. So if I type in my browser 192.168.1.201, I am getting the Apache test page of the CentOS distribution, which is basically coming from my 201 web server or the physical host itself. Let me show you the TCP dump of my VM1. It has not seen any traffic as yet. So from where is this web page coming from? Naturally it is coming from my Xen host, and if I do tail/various log http access log, you see that a page was accessed Okay, we can make it more meaningful by using various www.html index.html, and we can say heading 1 XEN physical host, and we can also specify a horizontal ruler just to be sure. And let's check the list of this. Let's check the permissions of this file, and it shows that it's world readable, so it should be served. Alright, so this 201 at the moment, if I try to reach 201, I am getting an actual web page from my XEN host, and just for the sake of completeness, I would do the same on my KVM host, which is at the moment out of discussion. Header 1 KVM physical host h1 and horizontal ruler. Okay, that's all. Okay, so if I reach 202, I should see KVM physical host, right? You just saw that the message or the web page changed. Alright, our objective is that when we type in 201, we should be redirected to a VM, virtual machine 1. This virtual machine 1, we should be redirected to it. Alright, so to do that, we are supposed to introduce a DNAT rule in the pre-routing chain here, which doesn't get affected by the default libvirtual rules, as we have seen so far that libvirtual rules get added in the NAT table. They get added to the post routing chain only, and once we are redirecting traffic, we don't have to do anything with the post routing, so we can let libvirtual play with this chain. We can safely add our rules to the pre-routing chain here. And how do we add that? Let's say IPTables minus tnat minus add to pre-routing and minus incoming interface Ethernet 0 trying to go to destination port 80 on port protocol TCP destination port 80, then do what? Minus j dnat minus minus 2 destination. Which destination? 192.168.122.41. Oops, to destination. Alright, the rule added because it did not give me any error, so I can just check using IPTables minus list minus tnat, and I see my rule added here. And if I do IPTables save, I can show you that here is my rule which I added. It's exactly the same as I typed in on the command. Okay, IPTables minus tnat, this serves minus tnat minus add to pre-routing, incoming interface Ethernet 0, protocol TCP, trying to reach port 80, then dnat that packet, sorry, not pocket, dnat that packet to another IP, which is this one, right? Alright, so let's see if we see any traffic. Okay, at the moment this rule says that it has not seen any packets, this particular rule. The pre-routing chain itself, overall it has seen some packets, but not this particular rule. Alright, we will try to reach 201 again, and this time it says the same message. Why? Let's see if we get any packets here registered on the pre-routing chain. Okay, the pre-routing chain has not seen any packet, and this is perfectly alright because I'm silly enough to present on a KVM host instead of the XEN host, and I'm trying to reach XEN host here. Silly me. Okay, let's switch terminal, XEN host, and add the rule here, IPTables minus tnat minus add to, or do you want to see the table first? That's easily doable. Minus list minus tnat minus list. There is no pre-routing rule here. IPTables minus tnat minus add to pre-routing, and what do we add? Packet coming in over Ethernet. Oops, sorry, coming in over Ethernet 0. Protocol TCP trying to go to port destination port 80 and do what with them? Minus j dnat, and I would go to the next line. Dnat minus minus 2 dash destination 192.168.122.41. Press enter. Check the list. And you see your rule here. If you do IPTables minus save, this is a one command, you see that your rule is added as it is to the pre-routing chain. Rest of the rules are from the post-routing chain. Alright, so this rule is added. Now let's check the stats. IPTables minus list minus tnat minus list and minus v for verbose, which will display stats or counters. So it says that pre-routing chain has so far it is in accept state by default, and has so far accepted 783 packets. However, our rule, none of the packet has matched our rule as yet. Let's try to do that. If I do a refresh, this time I'm getting an error. My Apache web service is running, still running on XEN host. I can show it to you. However, we are not concerned with HTTPD service running on XEN host, because we want to reach the traffic on our virtual machine. So when we do that, by introducing a dnat rule, this one, we should ideally be skipping the HTTP service on the XEN host, which is exactly what we are seeing. But however, we are not seeing the second part, which is we are not reaching VM1 here. The TCP dump window still shows that there is no packet seen for port 80. Alright, let me show you the stats of the NAT table. Here it shows that one packet of 60 bytes has been registered or has been denatted to this IP. That means this rule has seen at least one packet described in its condition. That's good. So where is our packet stopping? Let's check the filter table. I can type -t filter, as well as I can simply remove the whole thing and it would still show me the filter table. Alright, what's happening? Input chain has still not seen anything, at least the rules. The chain itself has seen a lot of packets, but not these four rules. Similarly, the forward chain has not allowed any packet as yet. Okay, however, it has seen one packet and it has rejected one packet. See this? This is exactly where our packet which arrived from DNAT, it stopped on the forward chain, and we were only able to see this error web page immediately because of the reject rule here. Reject with ICMP port unreachable. That is the message we got. Now, why did this happen? Why the above rules did not cater or did not honor this packet? Let me show you again. IPTables -save will help me explain. Now, as you know that from the pre-routing, as soon, okay, let me rephrase. Let me show you the diagram. I initiated a web request from this laptop. It went all the way to this XEN host, it reached the physical interface, outside physical interface. The DNAT rule was already there on the pre-routing chain, so that got into effect, and it tried to send and try to redirect or try to throw that packet to VM1. So once it's trying to being sent to VM1, it is supposed to cross the forward chain. Now let's examine the forward chain. We have already seen the pre-routing chain. Examine the forward chain. Remember, we are trying to come from Ethernet 0 and we are trying to go towards virtual bridge 0, right? Okay, let's evaluate. Physdev in. We are not coming in from virtual machine, so this rule does not apply. We are trying to go to this destination and outgoing interface virtual bridge 0. Yes, we are. This condition satisfies our packet. However, our state is not related or established. We are a new packet. Look at the diagram. We initiated a web request from here. So our packet is a new packet, not related or established to any previous communication. So this rule sadly does not satisfy our packet. So it moves to the next rule in the chain and says source 192.168.122.0. No, our source is this laptop, or if it's being DNATed, our source is this .201, the public IP. It is not 192.168.122. So this rule also does not satisfy. I mean this one. Our source, this rule says if the packet has this source address and is trying to come from virtual bridge 0. No, our packet does not have this IP and it's not coming from this interface. It's coming from Ethernet 0. This rule also does not get satisfied. So we move to the next chain, next rule in the chain, which says the packet comes from virtual bridge 0 and goes out to virtual bridge 0 should be accepted. Whereas our packet is coming from Ethernet 0 and trying to go to virtual bridge 0. So it does not satisfy this rule. What happens next? The packet moves to the next rule in the chain, and here there is no condition. Okay, there is a condition. It says if the packet is trying to go out to virtual bridge 0. Yes, exactly. This is what our packet is. It's trying to go out to virtual bridge 0 with no other further conditions. Then do what with it? Oh, sadly, reject it. And if I show you this, I think I showed you earlier, yes. This is exactly what's there. It has seen one packet of 60 bytes and it has rejected it. Now, how do we solve this? Let's close this video session here, and I will explain that in the next session, because the timer of this video is already up. It would become a bigger file if I don't stop here. Right, see you in a bit.